A journey through time, fact or fiction. The idea of time travel has captivated humanity for centuries. Imagine stepping into a machine and being whisked away to a different era. Perhaps you would witness historical events firsthand or meet your ancestors. Or maybe you'd journey to the distant future to see the marvels technology has wrought. The allure of time travel lies in its potential to rewrite history, explore the unknown, and even defy death. But is such a thing truly possible? Or is it merely the stuff of science fiction? While we may not have time machines zipping us back and forth through the ages just yet, modern science suggests that time travel, in some form, might not be as far-fetched as we once thought. The journey to understanding time travel begins with a fundamental shift in our perception of time itself. No longer can we view time as a rigid, unchanging constant. Instead, we must embrace the mind-bending concepts proposed by Albert Einstein's theory of relativity. Einstein's universe time is not what we think. Albert Einstein, a name synonymous with genius, revolutionized our understanding of the universe with his theory of relativity. One of its most intriguing implications is the concept of time dilation. This theory proposes that time is not absolute but rather relative to the observer's frame of reference, particularly their speed and the strength of the gravitational field they are in. Imagine two identical clocks, one on Earth and the other traveling at incredibly high speeds through space. According to Einstein, time would pass slightly slower for the clock in motion compared to the clock on Earth. This difference in time, though incredibly small at everyday speeds, becomes more pronounced as we approach the speed of light. While we may not have spaceships capable of such speeds yet, time dilation has been experimentally verified using atomic clocks. These incredibly precise timekeepers have shown that time does indeed pass slightly slower for objects in motion, just as Einstein predicted. This concept of time dilation opens up intriguing possibilities for time travel, suggesting that perhaps time is not as insurmountable a barrier as we once believed. Wormholes shortcuts through the cosmos? Another fascinating concept that emerges from Einstein's theory of relativity is the existence of wormholes. These theoretical objects are essentially shortcuts through space-time, connecting two distant points in the universe. Imagine folding a piece of paper in half and poking a hole through it. The hole represents a wormhole, providing a much shorter path between the two sides of the paper than traveling along the surface. In a similar way, a wormhole could potentially connect distant regions of space-time, allowing for travel over vast distances in a much shorter time than would be possible through conventional means. Some physicists believe that wormholes could even connect different points in time, acting as gateways to the past or the future. However, there are significant challenges to overcome before we can even contemplate harnessing the power of wormholes. For starters, their existence remains purely theoretical, and we have yet to observe one directly. Furthermore, even if wormholes do exist, they are predicted to be incredibly unstable and short-lived, potentially collapsing before anything could travel through them. Cosmic strings. Loops through time? While wormholes offer a tantalizing possibility for traversing the vast expanse of space and perhaps even time, another theoretical phenomenon known as cosmic strings presents an equally intriguing, albeit speculative avenue for time travel. Cosmic strings are hypothetical defects in the fabric of space-time, remnants of the universe's earliest moments. These strings are thought to be incredibly thin, far thinner than an atom, yet possessing immense density and gravitational pull. Picture them as long thread-like structures stretching across the vast cosmos, warping the fabric of space-time around them. Some physicists believe that if two cosmic strings were to collide or move in a particular way, they could create closed time-like curves, essentially loops in time. These loops could theoretically allow for travel into the past, though the exact mechanics of such a journey remain highly speculative. However, like wormholes, the existence of cosmic strings remains purely theoretical. Detecting these elusive objects, let alone harnessing their potential for time travel, presents an enormous challenge for scientists. Black holes, those enigmatic cosmic monsters, are perhaps the most extreme manifestation of gravity's power. These collapsed stars possess such immense density that not even light can escape their gravitational clutches. But their influence on time is equally profound, warping it in ways that boggle the mind. As you approach a black hole, time begins to slow down. This effect, known as gravitational time dilation, is a direct consequence of Einstein's theory of general relativity. At the event horizon, time comes to a standstill from the perspective of an outside observer. Falling into a black hole is a one-way trip, and the extreme gravitational forces would likely tear anything apart. The prospect of time travel, while captivating, also raises a plethora of paradoxes that challenge our understanding of cause and effect. Perhaps the most famous of these is the grandfather paradox. Imagine traveling back in time and accidentally killing your grandfather before your parent was even born. If your grandfather died, then your parent wouldn't exist, and neither would you. But if you don't exist, how could you have traveled back in time to kill your grandfather in the first place? This paradox highlights the potential contradictions and inconsistencies that can arise when we tamper with the past. It suggests that time travel, if possible, might be governed by rules that prevent such paradoxes from occurring. But what those rules might be remains a mystery. One possible resolution to the grandfather paradox lies in the concept of alternate timelines or parallel universes. Many worlds, many possibilities. The many worlds. Interpretation of quantum mechanics offers a potential solution to the grandfather paradox and other time travel conundrums. This interpretation suggests that every time a quantum measurement is made, the universe splits into multiple parallel universes, each representing a different outcome of that measurement. In the context of time travel, this could mean that traveling to the past doesn't alter your original timeline, but instead creates a new branching timeline. So, if you were to travel back in time and kill your grandfather, you would only be altering the course of events in that particular timeline, not in the timeline from which you originated. While the many worlds interpretation provides an elegant solution to the paradoxes of time travel, it is important to note that it remains a highly debated topic within the scientific community. There is currently no experimental evidence to definitively prove or disprove its validity. Quantum leaps. A tiny chance for time travel? Quantum mechanics governs the behavior of matter at atomic levels, known for its bizarre principles. Quantum entanglement links two particles, no matter the distance. Changes to one particle affect the other instantly, as if communicating faster than light. Some physicists believe entanglement could help manipulate time on a quantum scale. Imagine sending an entangled particle through a black hole's gravitational field. This might offer a glimpse into the past or future of the particle, but using quantum mechanics for time travel remains theoretical. The future of time travel, possibilities and challenges. The quest to unravel the mysteries of time travel is still in its infancy. While the theories of relativity and quantum mechanics provide tantalizing hints, we are far from building a working time machine. The challenges are immense, requiring advancements in our understanding of gravity, quantum mechanics, and the very fabric of space-time. However, the pursuit of time travel, even if it remains elusive, pushes the boundaries of our scientific knowledge and inspires us to imagine the seemingly impossible. Perhaps one day, armed with a deeper understanding of the universe, we will unlock the secrets of time and embark on journeys that were once relegated to the realm of science fiction. Conclusion: a universe of endless wonders. The universe is a vast and mysterious place, full of wonders that we are only beginning to comprehend. Time travel, once the realm of fantasy, is now a subject of serious scientific inquiry. While we may not be hopping into DeLoreans or traversing wormholes just yet, the theories of relativity and quantum mechanics offer a glimmer of hope that time travel, in some form, may one day be possible. The journey to understand time travel is ultimately a journey to understand the universe itself. It is a journey driven by curiosity, imagination, and the relentless pursuit of knowledge. And while the destination remains uncertain, the journey itself is a testament to the boundless potential of human ingenuity and our unquenchable thirst to explore the unknown.